So apology for the delay is the train company to be blamed. Sorry. And so today we have Olivia, Bailey, and her colleagues from Arup that are coming all the way, having the trouble with the tram and make the journey, and to share with us what they're doing in the Arup about digital water solution. Olivia, she was our previous YCDC students and finished training here, and now working with the company, and we are looking forward for a broader opportunity working with you.
Thank you, thanks. Yeah, hi everyone, sorry that we're a bit late. Press on. Yeah, we're just going to give you an introduction a bit to the work that our team does and Arup, if you're not familiar with Arup. So just by way of introduction, so I'm Olivia Bailey. My background is chemical engineering originally, and then, as Albert said, I was here 10 years ago. I worked out last night, which is slightly scary, to start my kind of digital water kind of pathway, I guess. So I was focused on wastewater systems modelling, and then my current focus now is kind of working on water smart communities, wastewater networks, and environmental markets. So I'll tell you a bit more about that later.
Brilliant. Hi everyone, thank you so much for having us. Apologies we are late. We've battled trains all morning.
Please continue, I just check the sharing screen for people online.
My name is Bhavik, Barochia. I sit within the same team as Tom and Liv at Arup, and my background's a bit unusual for a kind of a water person. I worked clinically with patients as a clinical microbiologist. And then have moved more into public health over the last few years, and I lead some of our work related to wastewater surveillance for pathogens and infectious diseases, as well as kind of chemicals in wastewater systems.
I'm Tom Doyle, background in sort of civil engineering and data science, and I lead a lot of our work around sort of water technology and innovation in the water sector in the UK. I guess it's a bit of what we're going to go through today. I'll run through like a bit of an introduction in terms of who we are as Arup, where we sit in the water business, and generally sort of some of the stuff that we do. I'll talk a little bit around some of the sort of technology tools and projects that we've been using in the water industry, and then we've got a few project-based, which Liv and Bhavik are going to run through. And then at the end, hopefully, have a bit of sort of discussion around how we typically work with partners and some potential opportunities to collaborate with universities and how we've done that in the past. Cool. So I don't know if for those that don't know Arup, we're firm, sort of 18,000 plus members across the world, sort of designers, engineers, specialists, data scientists, sort of 90 plus technical disciplines, water being one of those, which we're going to touch on today. And I think we've got projects in around 140 countries with offices in, I think, 35 of those. Some of the stuff that we're known for, so we do quite a lot of building work and known for things like the City Opera House. We do a lot of work around designing sustainable cities and the infrastructure they depend on, sort of energy, transport, water, the likes. And we do a lot of stuff around climate and water, which we're going to sort of be touching on today. We've got a little bit of a video just as a bit of sort of introduction into some of the research work that we do in the water sector, just to give you a flavour.
We use water constantly without really being aware of it.
Water is life, as they say, and it's not just a cliche.
It's really crucial to everything that we do, from taking a shower to drinking water to cooking food.
In higher income countries, we take for granted safe sanitation, the things that we've had for generations. Could you imagine carrying the water that you require for a day in your arms?
water there is in the environment, and to be able to look at that supply, it's understanding the differences between sources. Often the deeper wells have much better water quality. It's much more difficult for contaminants to migrate into the ground. The risk of fecal contamination is significant. So data on fecal coliform is one of the key things that communities should be able to test for.
The public health benefits of us improving the quality of our water supply, or indeed ensuring we have safe sanitation, is something that 2 or 3 generations ago was really appreciated. Diseases like typhoid and cholera are things of the past for us, but very much of the now for many people around the world.
Water as a source is generally reliant on rainfall, and floods are really just large amounts of rainfall within a particularly short space of time.
We're looking at how we can use satellite imagery to identify land use and how that might contribute to runoff, which would be part of how we assess a flood.
Different types of land use have different hydrological parameters associated with them, such as the level of runoff you can get. So by changing a land use, that means that you might be able to reduce the flood risk for a specific area. We use high resolution satellite imagery. It's 0.5 meter resolution, and by labeling each individual pixel in the image according to its land use, that allows us to get a really high resolution map that can be used in the national flood management design process. So in this pilot project, we used urban areas, woodlands, fields, and also field boundaries, but it can easily be extended to have more fine-grained types of land use. By looking at historic satellite images, we can look at how the land use might have changed over time, and we can start looking at how that might have changed the flood risk in that area.
As our climate's changing and we're getting more extremes, maybe water courses that had much lower flows gave us this sense of confidence that we could develop and encroach. And as that climate starts to get more extreme, we get caught out. Research helps to inform our understanding across key themes that are currently affecting or we think will affect the world. It provides business insights so we can understand practically what we can do about these things. Our actions then contribute to a resilient and ultimately much more sustainable world.
You really solve the problems that people face on a day-to-day basis. So there's a lot of personal reward from doing that. And I think as well, in the broader picture, contributing to the UN Sustainable Development Goals is a really worthy thing. And I think it's a really good thing for Arup to do as well.
Hopefully that gives you a bit of a flavour around some of the research we're doing, I guess. Something to say. So Arup are owned in trust, which means that we're able to invest some of our profits as a commercial organisation back into doing research and things that we think contribute to a more sustainable world, which is what our business has landed in. So for us, sort of the UN Sustainable Development Goals define what better looks like, and most of our, all of our work is aligned with trying to achieve one or more of these goals. For water, a lot of the sort of drivers of our work are associated with things like too little water, so things like droughts, too much water, so dealing with flooding and sort of increased risk of flooding events, and then sort of dirty water, so pollution and things like river health. We, as a sort of digital water team in Arup, sit as part of a sort of wider digital services portfolio, which is part of our water business, and a sort of high level overview of what we do. We work across sort of all aspects of the water cycle. We just picked out like a few things here which we're going to talk a bit more about today, but everything from designing sort of water infrastructure through to developing tools that are about sort of identifying nature-based solutions to manage water higher up the catchment. I'm going to talk about just maybe 2 or 3 of those tools, and then I'm going to pass over to do a couple of project based. So some of our digital solutions, I think it was touched on in the last video there, so I might skim over this, but we've got a tool called Terrain, which essentially looks at satellite imagery to identify how land use is being used, and we then sort of use land use data to identify areas for implementing nature-based solutions. We've used this tool in places like Shanghai to design the urban drainage master plan, to places like Mansfield in the UK to help water companies unlock, I think, millions of pounds in sort of climate finance. I won't go through the video because I think sort of one of my colleagues alluded to it in the previous video. Perhaps we'll pause on this one now. So another of our tools is called Nature Insight. And maybe I'll sort of, I've got a couple of minutes video which explains how it's used.
Changing the threats local communities face. There's an urgent need to manage growing flood risk, restore damaged habitats, and reduce emissions by sequestering carbon. We have developed a tool to help you do all three sustainably. Nature Insight is a user-friendly, map-based hydrological modelling tool from Arup and Scalgo. This tool will empower you to rapidly identify opportunities for nature repair wherever you are in Great Britain. Nature Insight enables practical, cost-effective, nature-based solutions that can help areas achieve their local climate action plans and other targets. Land managers and local authorities can use Nature Insight to zoom in and identify areas of land which have good potential for nature-based improvement. You can use the tool to instantly calculate the volume of water that could be stored and the impact of this on flows, the amount of carbon that could be sequestered, how much habitat could be improved, and the cost of any intervention. Nature Insight is the perfect tool for engineers and designers, planners, and local authorities who need to conduct rapid but detailed local assessments. It's an affordable solution for individuals or teams. It exports reports and data that build real insight within your organisation. The goal is to empower you to take effective action on the ground. Using Nature Insight, you can speed up the use of nature-based solutions as you tackle local climate risks wherever they are in the country.
I should say on that as well, so a lot of the time we're developing sort of tools internally, but also a lot of the time, in this case, with Nature Insight, and similarly with Infotile, we're working with sort of technology companies, startups, sometimes academics, to sort of develop tools and products in collaboration. The sort of final example of which is Infotile. We're working with a sort of Norwegian startup, slightly different focus, is more around trying to solve water industry challenges around things like smart water asset management. So sort of predicting when events like pipe blockages or river pollution events will occur, as well as how to sort of optimise water and wastewater treatment works operations. And the final one of which is, I think is a very segue to Liv, is a digital platform that we've been developing in partnership with an organisation called Entrade, who are a spin-off of Wessex Water. And maybe I'll pass over to you to sort of talk a little bit around what we're doing with them.
So we've been working with Entrade for several years now, developing environmental markets. Not typically my background, but it's been really exciting for me to kind of be involved from an Arup perspective to work with them, and we've just kind of launched a new business. So Entrade's kind of split away from being a subsidiary of Wessex to being a standalone independent entity, which kind of YTL, who owns Wessex, and Arup have jointly invested. So that's a little picture of our launch event that happened last month. So that's really exciting. Entrade are essentially a market operator, so they bring together buyers, which are typically kind of developers, and suppliers, who are typically landowners that want to kind of have environmental projects on their land, and we bring them together, and they can kind of exchange environmental credits, which are linked to environmental services. So historically, we've done it for biodiversity net gain and nutrient credits, but we're looking at kind of other ways we can use marketplaces, which I will talk about a bit on the next slide. So how it works is the buyers kind of bid for credits. They say, I want X number of credits, and they provide a bid of whatever they're willing to pay, like the maximum they're willing to pay. And the suppliers do the same for offering their projects. They say, I want to offer it for this cost. And then through kind of a matching and surplus allocation mechanism that was actually developed by the University of Exeter, the buyers and suppliers are matched, and there's usually a surplus, so difference between the bids and the offers, and that's shared kind of equally between both participants. So the buyers get kind of some of their money back, and the suppliers get a bonus on their project. So yeah, and how Entrade get paid from this is that they charge a fixed fee for market for offering a market, and that's kind of clearly published at the beginning of every market round. So yeah, the kind of selling point of Entrade is that it's a really transparent, fair, efficient market. That's kind of the goal that we have. And yeah, trying to get private finance into nature recovery is the real goal with these marketplaces. And I now have another short video that just talks a bit about the digital platform that we're developing that Tom mentioned, and a bit more about Arup's involvement in the company.
Integrity is really important to Arup. It's enshrined in our values, and it's part of what makes us come together as a company. And the government is driving building as part of its key policy. So it's really important that infrastructure builders have sustainable solutions where they can mitigate the impacts of their infrastructure development. So what we're doing at Entrade is developing high integrity nature markets. What that means is we can bring together infrastructure developers and suppliers using digital tooling and track exactly the environmental improvements that are being taken. It's good for Arup because what we want to do is underpin the principle of fairness and transparency in the work we do.
The biggest obstacle we faced has been the deep distrust of the use of markets in delivering environmental outcomes. So I see digital as enabling a fundamental paradigm shift in how we deal with the challenges facing the natural environment. Digital infrastructures can facilitate the integrated delivery of clean energy, improved water quality and nature recovery, facilitating a step change in investment in environmental improvement. And that's what markets fundamentally do. Markets enable the efficient delivery of verified environmental improvement on the ground.
For us, Entrade is all about environmental recovery, sustainability. Therefore, when we designed the platform, we had to architect and code in a way that aligns with those principles and those values.
We were very clear from the start that we wanted to make sure this was the sort of environment sits on cloud services, AWS in this particular instance, so that we can spin up the resources as we need them. The main thing there is that it uses less energy, so it's very much aligned with the Entrade philosophies, and so we were really keen to follow down that same path.
The digital underpins the basis on which we quantify and provide evidence of the environmental benefits delivered by our markets. We've used, for example, a standard to quantify the pollution reduction delivered by nature-based projects and deliver the level of regulatory certainty required by the regulator in our markets. So market integrity is going to be essential, and for us, digital will be a key way of enabling that market integrity.
if I escape and then it goes. Okay.
Yeah.
Oh, okay. So yeah, our work with Entrade has kind of gone all the way from design to delivery. So yeah, as I mentioned, we've run several biodiversity net gain markets and nutrient credit markets. But we're also looking at other ways in which we can use markets to kind of get finance into nature recovery. So we're working with the Greater London Authority, the GLA, to kind of use markets to kind of upscale sustainable urban drainage systems. So that's currently running. We've run kind of a first phase, and now it's in the second phase of that. And then we've also kind of looked at the feasibility of using markets for water efficiency. So yeah, kind of incentivizing people to kind of use water-saving devices and getting water companies involved in that. So then the next project I'm going to talk about is a project that we've been working on for a few years now. It's an Ofwat Innovation Fund project called Enabling Water Smart Communities. So this is an example where we're working with a large consortium of water companies, academics, and small and medium enterprises, and yeah, funded by this Ofwat Innovation Fund, which I'm assuming people are aware of. So Enabling Water Smart Communities is a project where we're exploring the relationship between integrated water management and housing development to unlock new opportunities for collaboration and delivery and long-term stewardship. So this is the project vision. So what do we mean by water smart communities? So it's essentially where the assets and systems required to for a place to become more water efficient are included at design stage and built into the real fabrication of a place. But it's also about the members of the community understanding, kind of valuing and taking ownership of those assets and systems, and to enable the reduction of potable water use and making use of alternatives. So during the discovery phase of this project, we identified blockers associated with the development of developing and adopting integrated water management systems in the UK. And we identified kind of what needs to happen to remove and resolve these blockers. And we named these enabling actions. So we came up with 65, so quite a long list. And they all kind of fit into these three main themes of stewardship, value, and assets. So we're now implementing a set of priority enabling actions through these various work streams. So this slide just shows the kind of range of partners that are involved in this work. So yeah, from kind of water companies, academics, to kind of companies involved in kind of housing and policy space. From those kind of 65 enabling actions, we're currently running a selection of projects to address these challenges. So these projects range from kind of how you support stewardship, community-led stewardship of sustainable drainage systems, primarily how you kind of what we built a roadmap for kind of how you how we can achieve kind of greater water reuse in the UK. How do we get there with water companies and policymakers, and then we're also looking for all the way to kind of how you finance these systems and innovative ways that we can get money into the sector. So I'm going to speak a bit more about one of these projects that's highlighted there, so the impact of reduced water usage on sewer network. basically because this is my project, but it's also very close to my heart because it was actually the subject of my PhD research. So yeah, this is a great example of kind of how we can take kind of academic research and kind of bring it to the fore. So yeah, this project is essentially from being part of the Enabling Water Smart Communities project. It became apparent to me that people were asking questions of like, oh, we're doing all these water efficiency measures, but like, oh, what is that going to impact? What's the impact on the kind of downstream network? And people weren't really aware, and people were suggesting, oh, maybe we need to do some research in this field. Da, da, da. But obviously, I knew that there is a body of research in this field, but maybe it's just not accessible really to the water companies and people implementing kind of water efficiency measures. So there's three main elements to this work. So the first is kind of making the knowledge accessible. So we're creating a kind of easy-to-use pamphlet, is what we're calling it. But this will kind of set out the main concerns, opportunities, and general impacts that you might see depending on your kind of water conservation measures. But this is essentially just taking academic journal papers and making them a bit more digestible for kind of water companies and other people that need to look at them. The second kind of main output is that we're converting a MATLAB code that I developed in my PhD into Python so that it's openly accessible, and also I'm not really a software developer, so we're making it kind of better and easier to use for the people that will use it in water companies and developers and consultancies, etc. So this code kind of stochastically generates household discharge patterns, which can be used as an input to network modelling tools. And we've also brought in some of my old colleagues from KWR to support as subject matter experts on this conversion, as the kind of original drinking water version of the software was developed by them. So yeah, that's another way we're working with researchers. And then finally, we're also creating kind of a high-level rapid assessment tool from this, which will kind of support go, no-go decision-making at a high level for planners to assess kind of impacts of various water use scenarios without doing the detailed modelling. So that's kind of the three kind of key things that we're working on with this project. So just a little bit more detail on the kind of model itself. So SimDM was originally developed by KWR in the Netherlands. So it builds kind of bottom-up demand and discharge patterns based on population statistics and which appliances you wish to include in your community. So yeah, you could simulate low flush toilets, grey water reuse, rainwater harvesting, etc. So that you can build up kind of house by house the demand and discharge pattern that you're likely to see in your future water use scenario. So this really improves on the kind of typical top-down model that water companies typically use for their kind of planning. When you're looking at water savings and changing behaviour. So so just to kind of sum up this enabling action project, we're aiming to kind of provide the knowledge and tools that allow people to make assessments on water use and enhance confidence when they're making decisions, and really to like bridge the disconnect between organisations, water owning companies, sewage undertakers, developers, etc. Because they should all have somewhat access to some part of this tool. So then I'm going to hand over to Bhavik to talk a bit about public health.
Amazing, thank you, Liv. So, you've heard the conventional types of projects that Arup do, very, very much aligned to what you're thinking around digital water is. This is something a little bit left field, which is slightly different to what you may expect Arup to be involved in. But sticking on the topic of wastewater, when we think of our water systems, we think of our distributed water systems, we think about how water interacts with nature, how it interacts with our urban systems. We consider it in kind of two forms, our clean water systems and our dirty water, our wastewater systems. And then we talk about surface water and groundwater and all the various different types in slightly different contexts. But what kind of sits centrally to water is definitely the impact it has on life, whether it's sustaining life through our clean water or it's reducing the risk of disease by improving sanitation through our dirty water or our wastewater. And because it's so central to life, it's a fantastic carrier of information. And so when we think of things like epidemiology in a traditional context from a microbiologist is a mechanism by which we track the spread of infectious diseases. And historically, this has been done through very typical means, taking nasal swabs, looking for pathogens in GP surgeries, looking in blood tests, all the typical ways you'd expect. But over the COVID pandemic, what actually evolved was something called wastewater-based epidemiology. Many of you may have heard of it, many of you may have experienced it, some of you may have even seen data on it. The process is very straightforward. Everyone goes to the toilet, everyone generates biomarkers, biological markers that enter our wastewater networks. They progress through our pipes and our sewerage, and then they can be sampled for at centralized wastewater treatment plants, at manholes, even directly at the toilet. The data can then be interpreted using traditional mechanisms like PCR and sequencing. We're able to get a better picture biologically, and using mass spectroscopy, we were able to get a better idea chemically about what is in our wastewater. This is incredibly valuable, and from the perspective of epidemiology, completely changes the game. If we think about how hard it is to get every single person in this room to find out about which infectious diseases we may be carrying. If someone's coughing in a corner, luckily no one is today, but if someone was coughing in a corner, to find out what's wrong with them, you would have to swab them, you would have to get an idea of what they've got as an infectious disease. What if you could just put a sampler outside this building, maybe at a centralized wastewater treatment plant, and still capture that information, that data? And that is what wastewater-based epidemiology is unlocking. And continuing on the theme of kind of how it works and what it does, you can sample at various different scales and different catchments. So you can look at the catchment scale through to the community scale, and then actually at a much more localized regional scale outside a building or more directly than that. And it gives us insights about the community, about the community health, and it is so much more cost effective than what we previously did in an epidemiology context. So it has significant benefits. And it's not just the benefits, it's the flexibility. Using wastewater-based epidemiology, we're able to very effectively gather insights about a range of different things. There's quite a lot on this slide here, but ultimately looking across the human health, the animal health, and the ecosystem or the environmental health context, we're able to get a really clear picture across that one health landscape. Human health depends on animal health, which depends on ecosystem health, and actually all three of those are totally interlinked. The example I always give is looking at our combined sewer overflow discharges into the environment often impacts some of the fish populations, and we find that things like mussels and oysters can carry human diseases as a result of those discharges. And so people often fall ill to norovirus from eating contaminated mussels. Now, this is very simple as an example, but it is where the human, environmental, and the animal ecosystems are totally interlinked. And ultimately, we are propagating diseases through these mechanisms. And what's central to all of those is water. And so when we consider wastewater-based epidemiology, we're not just considering wastewater in the context of our sewer networks, we're also considering it in the context of our wider water networks too. Being able to detect these various different markers, whether they're biological or chemical, will give us a much clearer idea of the health of our populations. So what did we do? Why does this matter? Well, we were working with universities. We were working with Bangor University in North Wales alongside Cardiff University in South Wales to help deliver the wastewater programme in Wales overall. The university teams were absolutely incredible. Fantastic scientists. There's some incredible publications, H-indexes all the way through the roof. But what really matters was, what do you do with this data? How do you make decisions with the data? And that's where Arup's role was, working with the universities very closely. Being able to understand what those insights are telling us, being able to engage the right stakeholders across government, industry, academia, but also more broadly, some of the healthcare agencies, the local authorities who are actually involved in making those decisions is absolutely key. And so across the various different scales, we were able to come up with a range of different use cases for wastewater-based epidemiology, and some of which we actually applied during the pandemic, and we've continued to apply beyond the pandemic. So looking at things like pop-up vaccination programs, early warning, looking at things like remote care as a concept, and looking at whether or not some of our nature-based solution strategies could potentially be delivering the health benefits that they claim to be, using wastewater data as that guiding line. And the programme in Wales was a great success. So from the onset of the pandemic, we worked very closely with the university teams in Wales to deliver the programme. It started from a small-scale pilot funded by research, and we were just there in a supporting context, but grew very rapidly into a real large-scale programme funded by the Welsh Government. Covering 47 municipal wastewater treatment sites, the programme was able to take samples 5 days a week and provide real-time information covering approximately 75 to 80% of the population. Monitoring COVID initially and then growing to a range of different infectious diseases, including influenza, RSV, looking at things like norovirus and polio, and then trialling things like chemical analytes, pathogens of protozoal nature, as well as culturable AMR, antimicrobial resistance genes. We were able to get a much better picture around the health of Wales, and that programme has continued. So we've not only supported the university in establishing the programme, but also in helping them engage the government to continue the programme and continue funding it. The programme was used to generate insights from the Bangor University lab, where they were doing all the sampling and the testing, and then the AMR sequencing lab in Cardiff University, where they were actually doing all the sequencing and collating all the data. Arup's role in this kind of evolved over time, so from program management and delivery of the program to kind of, working with the teams to make sure that they were able to deliver a large-scale national testing program, through to kind of how do we dashboard and detect the insights and make usable, actionable differences with the data. And so you'll see here some of the work that we did in that kind of digital water space, looking at the catchment scale, looking at local health boards, being able to dissect the different geographies and being able to understand the population coverage from each of the different wastewater treatment sites. Being able to easily and rapidly give people information about the level of different pathogens, and in this case it was the gene copies per litre that you see here, in their wastewater, to give them an idea of the level of circulating disease. As you collect more data over time, you build a better idea of your baseline, and you have a better idea of what's going on. And then finally, looking at different pathogen variants. So looking in this case at COVID variants, and looking at how those evolve over time and change. And you'll see from some of the data, you'll see the rise of Omicron, you'll see the rise of the Delta variant, but you'll also see new variants coming into place. And that data is still continuing to be generated over time. So Arup's role was part of a wider selection of collaborators and partners. So we worked alongside all of these different teams. Bangor University were the lead university, Cardiff University was supporting, but all of these various different bodies, whether they were the health agencies, whether they were different universities, I see University of Exeter is up there on the list, and you guys were also involved in helping deliver some of this program. Overall, working collaboratively, managing these stakeholder relationships and looking at how we can support the universities in delivering their ambitions around taking the research and making it incredibly valuable for society. But what was absolutely key was our relationship with the university teams. So being able to work with the research teams who have a really strong and very valuable understanding of the fundamental science, a very valuable understanding of how to develop the methods and actually decide on what to do with them. But then beyond that, being supported in delivering it into industry, being able to deliver it to government in a way that is accessible to government to then ensure that the funding continues. And that kind of brings us towards the end of this kind of presentation from all three of us here. The question we kind of pose back to you, and we would love to discuss with yourselves if we have time, is whether or not we can do something similar with yourselves. How could we work with yourselves in your respective research areas to help develop out the opportunities, to help you take some of your research and really put it into the public realm, and likewise, how we could be supported in delivering some of our work in the industrial world and towards the sector clients more broadly. So very much welcome and open up the floor to discussion. Please feel free to ask us any questions you may have, and thank you very much.
So we will have a very long afternoon to discuss more details, but anyone in the audience, would you like to ask some questions they have presented? Yes, Mohammed?
Can you explain just what sort of tools you've used in your model?
What sort of tools?
Yeah.
Within the model,
Yeah.
the sewage model. So it's based on Symdium, which is a tool developed by KWR. So that was originally a MATLAB code, but now has been converted into Python. So it's open source. It's like a stochastic generator, basically, for demand and discharge patterns. And then that can feed into InfoWorks ICM is the drainage model that I've used, but it could feed into very many other kind of standard commercial kind of drainage models. Basically.
Yeah. And does it provide any decision or
any
decision? Does it recommend a decision or an action?
No, I'm not sure what you mean by that, but no.
Because you simulate the demand,
Mm-hmm.
and from that, can you get some useful information and suggest something, or does it go that far?
So you set your you basically set your population statistics. You say kind of what water use strategy you want to kind of simulate.
Yeah.
And then within that, there's kind of a stochastic generator that will generate house by house kind of patterns, and then you can assess the outputs of all of those households.
So the user will assess the output, like.
Yeah. There's not like a standard assessment that says do this.
Yeah.
There's no kind of instruction, I guess,
Yeah.
that comes from it. It's providing data that then can be assessed on a case by case.
Cool. Thank you very much.
Yes.
Yeah. My question is actually, thank you very much for the presentation. My question is about all of these systems. So you gather the data. Mainly you have a satellite data somewhere, you have some data from where water treatment works. What I was thinking is you gather all these data, and these data all need a pre-processing. Are you doing the pre-processing before saving them in a space which it is usable, or it is go through the pre-processing, then saved, or it is saved, then go through the pre-processing? This is my question, really. Because it's a massive amount of data.
Yeah.
So this is the question.
Varies depending on different tools and projects. A lot of the satellite imagery stuff, I think a lot of the legwork is in pre-processing the data. And that terrain tool, for example, I think is trained on pre-processed data. So it needs to be pre-processed before the sort of training. I don't know about some of the other products and tools, probably varies depending on which bits of it. I guess a bit of sort of tangent to the question, we as sort of digital water team work with data scientists and software developers. We're not necessarily doing the data science and sort of technical aspects ourselves. We're trying to connect what's traditionally like, engineering businesses into sort of a new and emerging bit of Arup, which is sort of like digital capability. So a lot of that work probably is not a technical answer to because we're not the technical people doing it, but
Yes,
I think it varies.
with the wastewater program, it's quite different to the kind of some of the traditional digital tools, and that goes through a pre-processing stage with the academic team. So they will go through that within the research labs. That will be generated and then sent into the cloud, and then we have a cloud computing pipeline that allows for us to then go through a further range of further analysis in the cloud before it's then outputted into the dashboard. So there is pre-processing from some of the data collection side of things, but then there is further processing that happens with ourselves. We're using the domain knowledge and also the kind of capabilities. So some of the work we did with some of the wastewater data was actually some of the plain text outputs, and that was all generated within the cloud after the original data was collected. So the academic teams gave us effectively the raw data, or like the initially processed data, and then that data was then output for further analysis. But it does definitely differ from case by case. Different tools have various different requirements, also different client projects. So certain clients will want certain data analysed purely on their systems, and so we design or architect a solution that works best with what their requirements are.
This answers my question, actually, yeah. What I was thinking is it is not a full automated system for data processing, so thank you.
Yes, thank you very much for the great talk and for showcasing some of the amazing projects you have done. So, you have developed a lot of tools. My question is, what's your approach to managing these kind of tools? Mostly you develop them with partners or in-house. Do you, open them up to the public, or do you, merely keep within yourself?
It varies, yeah, it varies. I think we probably found that a few years ago, used to develop a lot of internal tools and products, and we're not a software company, so I think actually maintaining I think we work better when we work with technology partners. And yeah, I think that's the reality. I think a lot of the stuff we develop tend to try and make open source where we can. I think when we've got relationships with technology partners and startups, there's commercial sensitivity around what we can share. But I think by philosophy, tend to try and make our approaches open generally in our and publish a lot of that stuff on our website.
So like Nature Insight, for example, that's been published from what I understand. They're publishing some of the underlying work. That's what I've been told. So some of the work, like when we've developed it with academic partners, often those things are published. So the University of Exeter algorithm, I believe, is a published algorithm that then has been kind of evolved and developed further and put into some of the tools, but it does depend from tool to tool as to which ones are kind of more accessible, some of which are less accessible. The Welsh Government dashboard, for example, for wastewater was developed and originally completely closed off to external public use because the Welsh Government wanted it that way. And so when we have then looked at further iterations of it, it has to change a little bit for public dissemination, but there will be hopefully different bits that can be put into the public domain with the less sensitive information kind of kept the more sensitive information kept behind closed doors. So it does differ from project to project and client to client, but there are a number of tools which have been developed using open source code.
So the tool that I spoke about will all be open source and published because it's funded by Ofwat. So that's all going to be available, everything. And some of the others, there are fees associated if they're on platforms that are hosted by kind of external people or external partners.
Okay. So I'm afraid we need to close this discussion. Sorry about it, because there are people waiting out there for the next session. So anyways, thank you very much for this brilliant talk. We will continue to the discussion in the afternoon. And sorry for people online, we won't be able to allow you to have a question here, but hopefully if you have any question, feel free to contact Olivia, Tom, and Bhavik, and via the email you saw on the screen. So could you please join me saying them again?